Hello students, today I am coming with a small derivation but required mandatory. What is the derivation is derive the relation between electric field and potential. So an equation which give a relation between electric field and potential. So you know the work done derivation or definition, right? We know that the potential difference between A and B is the work done. Potential difference meaning is actually the work done. Okay. So potential difference between the points A and B is the work done to move plus 1 coulomb charge from point A to point B. See, I am drawing one charge here plus Q. Its direction of the electric field is towards right side. Consider there are 2 points on it, A and B, and distance between them is dr. Okay. What is our plan is, we kept 1 coulomb charge at the point A and planning to move towards left to the point B. That means making a displacement dr. So here dv is equal to dw as per definition, right? Okay. So we know that the expression for work done. What is the expression for work done? Work done is equal to force into displacement. Yeah. We want to know the force here. What is actually force is Coulomb's force, you can write. There are 2 charges plus Q and 1 Coulomb. So force between them will be 1 by 4 pi epsilon 0. First charge is plus Q, second charge is 1 Coulomb. So Q into 1C divided by distance between them is R. Okay. Make it R square. Okay. Into displacement here is dr. Displacement here is dr. Why there is a minus sign I kept? Because the work is doing against the existing repulsive force between plus Q and plus 1 Coulomb charge. Okay. So here the force, read this one is R square. I wrote it now. Okay. Now what next is, so we can say that this work done is dw is equal to, see, Q by R square is actually the electric field. Correct? Because into 1 Coulomb is, we can ignore it. So minus E into dr, or E is equal to minus dv by dr, or E is equal to minus dv by dr is the relation between field and potential. Remember, dr may be sometime dl, dA, just L, can be anything, distance between 2 points. Okay. Other point I want to discuss with you is equipotential surface. Equipotential, the potential is equal. That is the meaning. So the surface at every potential, but equipotential meaning is that surface at every point of which the electric potential is the same is called equipotential surface. So what is equipotential surface is? These are the surfaces, but the potential is same value. Okay. And one board question was there like this one. What is the work done required to move a charge from one point to another point within the equipotential surface? The answer is 0. Why it is 0? Because both places having same potential, no difference between them. That is the reason work done is equal to 0. Okay. This is a 1 mark question. Other one is another 1 mark question. Okay. And some important surfaces are shown here. For example purpose, because there are situations you want to draw also 1 mark question. For a point charge, how to draw the equipotential surface? For a point charge, a single charge, okay? This is the point charge equipotential surface marking. At the center there is charge. You know that there are concentric circles. Every point on the circle will have same distance from the center, so will have same potential, okay? Second, for uniform electric field, how to present the equipotential surface is, you can see here, this is the way you can represent the right side image, okay. And the third one, all are 1 mark question, okay. For an electric dipole, you know the dipole, yeah, dipole is the combination of 2 equal and unlike charges separated by a small distance. For an electric dipole, this will be the diagram for equipotential surfaces, okay. And for 2 identical positive charge, remember this can be same for 2 identical negative charge. There is a difference actually, the dipole and the 2 identical positive charge. The drawing there is a difference, and microscopically look into both the diagram, then you will understand, yes, there is a difference. Okay students, this much only for today. This is a small topic, but we don't want to ignore any topic. That is the reason I considered this also to make a video. Okay students, thank you. We'll see you in the next video. Bye.